you guys, and welcome to another night of Gulu Thursdays. So tonight we have Mr. Jacob here from
Hi
Gulu Gulu Learning
there.
Academy.
How's it going?
Yeah, yeah, awesome. Thanks for for being here, Mr. Jacob.
Thanks for
Um,
having me.
so you guys, we are going to talk about a couple of different things tonight. And let me just do a cool little switch. Okay, cool. So we want to go ahead and introduce to you a special class that Mr. Jacob is doing and something that is totally beneficial for all of our students and something that's really neat just in general to learn. But just, a quick little overview of just exactly what we offer here at Gulu Gulu is um, one, our most popular class, which is our pre-K circle time class, okay? And it offers all of the 5 subjects. And this is for our preschool students and for our kindergarten students as well. Okay, it offers the math, the language arts, the social learning, the science and art and music. Okay, it is all of those things. So it is a great opportunity for your preschooler or kindergarten to take advantage of and learn as much as they can. The next the next program that we also offer is our 12's Foundation program. And this is a really neat program because it offers the public education standards plus our private school setting with the homeschooling support system. Now, if this is something that you are interested in, it is a great opportunity for them to learn and having all of these benefits with the private school setting and the homeschooling support. Now, that is a really big deal, especially nowadays. And also, Gulu has so much to offer with all of these extra classes, activities, and supports. Okay, we have our math and science, our language arts, our social learning, tutoring opportunities, and arts and crafts. So for our math and science, we do have our math support classes and our coding class. Okay, and this one is like a coding is kind of like a science sort of though too, right, Mr. Jacob?
Yeah, well, it's computer science. Yeah,
Yeah.
principles of computer science, but it's actually a series of classes. We have like different levels. So we have
Mhm.
Scratch, Junior Scratch, as well as Tinker that we're going to be teaching as well, which
Ooh,
uses drag and drop
cool.
programming. Um,
Yeah, that is
yeah,
totally awesome. That's really great. Like it's cool because we do have the different like levels, right? Those are different levels.
Yep, exactly. So we can
Hmm.
start the younger kids at at the easier interface, and then they can move on to the more complicated interface and, higher end programming principles. So it's pretty good. It's structured and tiered so they can build up their knowledge base.
Awesome. That is really neat. And I cannot wait till we get into the other stuff and, check out what, the nitty gritty of all of this stuff. And yeah, and then show all of our viewers what it looks like and, in the perspective of a student. But before we get into that, we do carry our language arts, and you guys, we have a lot of language art um, opportunities. So we carry the phonics, the reading, writing, and grammar, language development. So if you want to venture out, have your children venture out into learning Chinese or Cantonese or improve on their English, we have we have what you need. And
Mhm.
then social learning. Okay, we offer life skills for children. Okay, the goal setting, social emotional knowledge, character building, money skills, you name it, it's there. Also, we are opening up 2 new things that I'm really excited to mention, and it is the tutoring opportunities and arts and crafts club. So we are now going to be offering um, in-person tutoring, and it will be available for all subjects. Okay, we are going to do homework assistance and also subject assistance. It's going to be available again in person, and there are online opportunities as well. And then we have the arts and crafts. Okay, so this is another class that we are going to open up, something that we are going to do on the Facebook Live, also in private classes, something that are planning to do for each end of the month, every Thursday, at the last Thursday of every month. We are going to do an arts and crafts kind of like activity together. So that is just, a little taste of what it's going to look like. Okay, and now finally we will get to today's topic, coding at Gulu Gulu, and the importance of coding for the children of the digital age. So go ahead, Mr. Jacob, if you want to go ahead and let us know about why coding, why do we need it, what's the big deal about it?
All right, well, I guess a good segue. So we teach other types of languages, and the way that we communicate with a computer is actually through digital language, which we call computer languages, like JavaScript, uh, all the Python. Those different languages are used to communicate with the computer, just like how we communicate through language. So in essence, we are teaching another language, and it's an important language because if you look around the world these days, everything around you is digital, and children are inundated with technology. People in general are inundated with technology. So coding gives you learning those principles kind of gives them a step ahead in terms of their understanding of digital technology and their ability to interact with computers, to interact with technology effectively.
Wild. Yeah. Like, and even, now everything is just technology that we're surrounded by it. The kids, obviously are around it, using it, playing with it and stuff. So totally.
Exactly. There's a quote that I like that says something like children these days should have the ability to be part of the computer science, the creative end of computer science instead of the consumer end, because
Mm.
a lot of people these days, they're the consumer of it, but with the with coding, you can, it's so creative and you can be so creative. So by being part of the creation aspect, they get to help create that instead of just here's what you're given. So it's pretty cool. It's kind of like a new, in a way, it's a new, not art, I mean, it does have art, there is
Oh, it
design in
is.
it.
It's
So
really creative.
there's a lot of, there's art involved. It's kind of interdisciplinary if you think about it, because computer science and its principles come fundamentally from mathematics. So it is very much interdisciplinary, both design and in our classes we teach principles of animation and structure and how to sequence different scripts so that it'll produce different results, that kind of thing. So it's pretty in-depth stuff. But what I think is really cool too is it also provides basic understanding of logic. So when a child is tasked with coding, they have to use logic. Like, how do I move this guy to here? So you use this many steps to go forward, this many to go down, and they actually have to plan ahead. And so for younger children, if you look at them like developmentally, that's a challenge. That's really a challenge, and it helps their brain to develop into that type of thinking that is, long term, thinking ahead and thinking
Seems like
more.
being a lot of like proactiveness.
Yeah, being proactive, as well as I'm kind of dropping the term here that I'm looking for, but they're able to think ahead and to think constructively. There we go. To think
Okay.
constructively and analytically, like, how do I get from here to here? And they have to actually plan it. So
Yeah.
when you're 5 or 6 years old, like some of our students who are learning
Hmm.
coding, when you ask them to plan ahead, that doesn't really make much sense, in terms of time. But when they see it
Yeah.
digitally in front of them and they see a character and they see like, oh, it's like real life, so he's got to move, then they can actually sit and start to think,
Hmm.
linearly in that manner.
Yeah, no, that is totally cool because I mean, I get it how kids are more or less, if they're going to do something, they're going to do it now, and then might not think of other things past that. You know, even thinking one more step ahead might be a little bit rough for them at
Always.
first.
Yeah.
Yeah. And then when you put them in a situation to create something, and it's something that they really like, it's their like work, and they have to program their brain to basically just
Exactly.
plan, to plan.
That's what it is. So that's, to me, that's the biggest thing, is that they're actually not just programming what's in front of them, they're literally programming their own brain because their mind is developing. And so
Mm-hmm.
by learning to think like this in this logical and linear manner, they are literally programming their own brain as well to, to think like that, to function like that. So it helps them, I think, to, kind of gives them like a step above in terms of like mental development, because they're
Mm-hmm.
thinking along the lines of like a mathematical, logical sense.
That is
So
really
it's cool
neat.
stuff. I think it's pretty cool stuff, actually.
It
I
is.
like it,
It
and
is
it's really
really neat.
fun. And I think too, my big thing with them when it comes to education is I think it should be fun,
Mm-hmm.
because when I was younger,
Yeah.
I would detach as a young student because it wasn't fun when I was a kid. So
Yeah.
coding is something that is actually pretty fun, and it's engaging, and they learn a
Mm-hmm.
lot from it because it's fun. So if I fundamentally think it's great to make education entertaining, and they're going to get
Yeah.
a lot out of it. So
I
yes.
feel like their hearts are more in it when they are, entertained and they're content, and it's just not like, oh, I'm being made to do this. Like,
They're going to retain
yeah.
more. They'll remember
Mm-hmm.
more because they actually are like, oh, this is cool. It's not, oh, I don't want to read about, how, there's a lot
How
of stuff
this
in,
and that.
yep, that can, yeah.
Things that they might not be completely interested in. But I mean, this is a valuable like skill though, especially with our like technology just consistently developing and developing and developing. We are getting more things being improved. Like this game stuff is just getting bigger and better, and more consoles, more games is being like made. I don't know, and these kids are playing these things, but it's kind of a big switch when you put yourself in the seat of like, okay, I'm gonna make something, I'm gonna make my own game the way that I like, and it's gonna look exactly the way that I want, and the characters are good. It's a cool way of thinking, like that they could be a creator of a game.
Right. Oh yeah, definitely. I think some
Mm-hmm.
of them are pretty proud when they make, they make a project, that kind of thing. You can tell that they're,
Yeah.
they feel like they've achieved something because it takes a lot of work, it takes a lot of thought, it takes a lot of planning, debugging when something goes wrong very
So what is
often.
can you explain what is a debug?
So, well, like a bug is like is like a glitch essentially. So sometimes when you're coding, the more script that you add, the script is the code that's presented. The more script that you add is in essence translates to more mathematical computations. So if there's more of it, it has to do all of this different stuff. And so then you're looking at the what they call like the architecture of the game, but the structure of it has to be correct, the sequence. It has to be in the right order so that it triggers correctly. Otherwise, this triggers this unintentionally, and it goes blah, 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 and then you see a
Oh.
glitch. Like if you've ever played a game and it was glitching, and you're like, why is it doing that? That's what's happening. So there's somewhere with
Hmm.
their code where it's triggering another piece of code or that kind of, and there's some issue with it. And so a lot of the times in my classes, they sometimes have issues with what they're programming, and so it could be frustrating. And so then they also have to think,
Yeah.
so they have to take like, well, this is what I thought would work, but there's something wrong with how I planned it, my own logic. So now how do I go back and
So
find
they're
where
problem solving.
they're problem solving, they're doing all kinds of stuff on a
Yeah,
right, yes,
troubleshooting problems.
troubleshooting, problem solving, planning. We use storyboards for some of the assignments. So because a game is just like a play, is just like a book. It has characters who present, text or present an action, a mannerism, a gesture,
Mhm.
that kind of thing. And so it's the same. Same thing. You have to plan it. You have to like, what's the setting? What's the plot? Where is it taking place? So it actually it's
Yeah.
very interdisciplinary, to be honest, in terms of like just skills from different different departments,
That's
math
really cool.
and art and
And then there's this the what is it? The story building.
the story building,
Right.
which is like pretty much is like what you would do in an English class when you're building a book or when you're making a play or when you're doing something, but you're doing it digitally, and very often you're even typing out the words that they're speaking. So just like if you played a game where it's like, all right, let's go.
Oh.
So the kids are actually, they have to type it. So they're getting practice writing, they're getting practice with their math. A
Hmm.
lot of my students, they now know what a XY coordinate plane is, where a lot of them that's like math beyond beyond
Oh
their
yeah,
years.
that's like something that you would start talking about in middle school.
And negative numbers
Yeah.
and they have to, because to be able to do scratch, not junior, but to use actual scratch, you have to use negative values, and they have to understand what that means, how numbers can, and decimals. So all the kids in my classes are being taught decimals without even, they're just using it
They
because
don't
they
even
have to,
notice.
and they understand that, oh, this is a smaller number, so they don't, they're not learning, they're not doing like the decimal practice, but they're seeing, oh, point 0.1 is smaller than point 0.2 is smaller than, so yeah, that's advanced math.
Hmm,
Too, so
yeah, that definitely is. That I guess like it's sort of almost like a cheat where they're teaching this higher and more complex math and they're not even noticing it.
yeah, because they just they have to use it functionally. It just makes sense when you're seeing it, because when you're like, oh, if I test this and point 0.1 makes them only go this fast, but point 0.2 makes them go this fast, and so on, they can
Yeah.
see the actual the actual effect of the change and how it's reflected in the game or project that they're working on.
Oh, that's pretty neat. I didn't know that was like a thing where the X and Y plane and then the point, whatever the point decimals.
Yeah, decimal points, and yeah, they call them operators. So once they get into actual scratch, that kind of thing, we teach them, I teach them like actual coding terms, things that they have to use. So they use operators, boolean as well. Boolean is like where you're looking at greater than, less than, equal to. So you have to take and structure, like, if it returns this value and if it was greater than 10, then it does this. If it wasn't greater than 10, then do this, that kind of thing. And
Hmm.
you put it together.
So, and you did mention before that there was like three levels to this. Can you show us what that first level looks like,
Sure.
in a student's perspective?
Yeah, like
That's
what,
kind of
like the kind of stuff that they might be seeing in the class, or like what we're
yeah. So
looking at.
the
Yeah.
first level, yeah,
Mm-hmm. Just one moment. Let me get it pulled up here.
yeah.
So this is Scratch Junior, is what we start with
Okay.
for the younger students. It's intended for students age 5 to 7.
5 to 7. Okay.
And it looks like this. So can you see this?
Yes.
All right. I can't, yeah, I can only see my screen, so I can't tell.
Okay. Yeah.
So this is Scratch Junior. When we work in class, this is what a brand new project looks like.
Uh-huh.
And this is a character. It's in Scratch, they call it a sprite. It essentially is a programmable object. You can attach code to it. And so they can
Hmm.
draw, they can change what the character looks like, and make them different colors, that kind of stuff.
Oh,
Work
it's
with the
so
character.
personalized.
Yeah, there's a lot to
Okay.
it. There's a whole bunch of different stuff. I don't know exactly because what I'll show you is just a little bit of coding, but you can also
Hmm.
add backgrounds. So we've got all these different backgrounds. Some of them I've used in other games, like this one here. You can see is made for a maze game, but there's a ton of different ones. You can make win screens, lose screens. So let's just for the purposes of this, we'll just grab this one here. So like if I had this character, so now there's a background, we have our object, and then we take and we give it code. So in the class, I would tell them about sequence. I compare coding to Simon Says, because in Simon Says
Mm.
you get instructions, and if it's the correct instruction, you win. If it's the wrong instruction, you're out of the game. And that's kind of how it is
Yeah.
with coding, because you need to give it the correct instruction. And so we start with like a series of little challenges. I say I wanted them to, walk over to this corner. They would have to get some code to go to the corner, so they could pull up this grid here, and they could actually count the squares to get over to the
Oh.
corner. And then they would take, say, a green flag. The green flag is an event control, so it starts our script. We'd put that there. We could say move over. And how many squares was it? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we'll say about 15 squares. So we put in
Okay.
15, we change this number, and we hit it.
Oh, so
So it's
cool. Okay.
pretty basic, this, but just to show
Uh-huh.
like another thing. So that I like to use, that's kind of like when we worked with the younger students as they begin to learn, that's the kind of stuff that they would be doing, because they're having to do the math, they're having to determine, how do I get my character to go to here. So once they actually know what they can do and how to do different stuff, then we start to put together other projects and actual games. So like, say we wanted him to dance, we could take some code and we could throw in some different motions. We could go like this, and then we could put another loop. We'll put a little timer here in between, and we'll put another loop where he moves up and down. And we'll put another timer
Mhm.
just so we can see it. We use the timer so that you can actually see the animation.
Uh-huh.
And then we'll just have him go like this. Dun, dun, dun. And we'll change this little control here. So instead of being with a flag, we'll make it so when we touch our character, he's going to perform this action forever. This is a loop. It's a continual loop. So when I touch him, now he dances forever, and he won't stop.
That's pretty neat. And then they have to go through the process of learning like each like symbol and memorizing them in
Oh,
order to work more efficiently too and quickly. So they build on like, memorizing and then being more like just faster, right?
well, exactly. And they have to learn how to, there's a lot. This is just like at a very base what you can do, because then you can add multiple characters and you can add different controls. So there's like when the characters touch. So if we say we had two characters, let's do it. We'll add another character here. So like in class, I would instruct the students, say like add another character, and they could add in this person, say. So this person, when I hit the green flag, we'll start walking to the right, we'll say 10. Him, if someone bumps into him, he's going to start dancing forever. So now she's been programmed to trigger, so if she touches him, he'll dance. If they don't touch, no dancing. So here they don't touch, we'll hit the flag. They don't touch. Now we'll put him there, hit the flag, and now he triggers and he gets
Oh, I
hit.
see.
And there are actual messages, so you can color code different messages to trigger different effects. So this is like, I send a message, this person receives a message. So maybe he dances and then he sends a red, or say this guy, after he dances, he sends a red message. Dun, dun, dun. When she gets the red message, so if she receives a red message, now she'll do a little dance herself.
Okay. That's cool.
so now she's going to walk into him. He'll start dancing. She continues walking. Dun, dun, dun. And now she starts her, her dance was short because there's not much
Yeah.
code and there were no repetitions. But so
Yeah.
that's just kind of the different stuff we do. And we put together projects with win screens, a victory screen, a losing screen. We can actually remote control these characters using these messages. So we teach them how to
Hmm.
actually build controls. And the whole time they are being tasked with, to take a project and create something with this theme or that theme using this direction and so on. And so they have kind of objectives as they're learning to do it.
Oh, I see. So then, um, can you show us a situation where they would have to like do the decimals and stuff? I'm pretty sure that's for the higher level,
Yep, that's for
like
the higher
scratch.
level. Yep. Do you want me to pull
Hmm.
that up now? Here, just
Yeah.
one. Before we jump out of this, let me show you. Oh, I may have, let me see here. Yeah, no problem. Let me jump out of this. Dun, dun, dun. I have so many projects on Scratch Junior. I really do. I have so many that it'll bog down and it gets really slow. So I could already tell it was gonna slow down for a second there. No
Oh,
point in
okay.
waiting. So yeah, so here, let me share. So now once we so that's for age 5 to 7. Sometimes we've
Hmm.
even had a student who was 4 who did fine in the class. Then Scratch gets
Ooh.
on to like age 7 and up, and it can actually go into high school. So, because coding is mathematics, so the higher your level of
Hmm.
math and the greater your understanding of that, the better, the higher level your code can be. So here
Yeah.
is actual Scratch.
Seems like that the children doing, the coding classes are gonna have a much easier time dealing with math once they reach, like middle school and stuff.
Oh, I
Now
would
that they
think
have a base knowledge.
I would think so, for sure, for sure.
Hmm.
So yeah, so you mentioned the math. So this is Scratch. It is a higher level of programming, and right here, right away, you can see that you're dealing with numbers. So they actually have to use degrees, turning degrees right here. Go to, so they can actually set a location. So let's say 120, 40. Over here, just like in Scratch Junior, is a coordinate plane. So when I hit this, see how he went to that location? If I change it
Yeah.
to 200, ding. So they
Oh.
have to learn. So say we make it a negative number, dun, dun, dun. Now he moves left. So to be able to use Scratch and to move a character around, they actually have to be able to understand the XY coordinate plane and understand that moving right is a positive value, moving left is a negative value, and they have to understand that with Y going up is positive and moving downward is negative. And then
Hmm.
stuff like this. So when it comes to like using point values, so you can use, well, yeah, right here, we'll use so for controls, so for seconds, you can have it wait literally like 0.001 seconds to make it happen quickly. So if we wanted,
Mm.
say this to happen, he'll turn, see how quickly it happens.
Yeah.
Now if we make this 10 seconds,
Is it moving?
yep, see, and it went back. That was so, yeah,
Oh.
because it had
It's
10.
so slow.
Yeah, because I made it exactly. You see how it affects the speed. So the time is actually the speed of the character. So when they get into this kind of Scratch, they're using more complex stuff. So like for
Hmm.
example, I'll make some controls really quick. So we'll add a event control for him to start when I touch the flag, and we will make him the entire time. If we hit a button, he's going to move a certain direction. So this means if I do this, then he will do this. And the entire time, if this happens, it'll occur because it's within a loop that says do it forever. So then I'm going to grab sensing, and I'm going to grab some key buttons here. Boom, drop these in. Da-dun, da-dun. And I'll go like this. I'll use W, A, S, and D, like I'm using my keyboard. So we'll make
Oh,
this.
like the game keys.
Yeah, like game keys. I could use up and down. It's easier with up and down, but I don't like it. WA. We'll use S and D here. We'll flip to D. So we've got W, A, S, and D. Then to
Uh-huh.
move them, we're going to use the actual values. So we're going to use change X. So W is going to be up. So that's actually going to be change Y. So now we've got up. So WA is going to be down. So that's going to be a -10. because it's going to move
okay.
downward. S, or I'm sorry, S. That's where I want to put that. A is going to be to the left, so it's going to use X as a negative value. And then D is going to be to the right, and we'll use X. There's my change, X change. There we go. By a positive value. So now when I run this program with the green flag, that's me hitting my keys.
Oh, I see.
So you can see.
Oh, so then they can, with this one, they can really, what is it? You call them controls. You can do the little controls to do the little game or whatever that they want to do.
Exactly. Yep, he's become remote controlled. Yep. So just as a basic example, so I'd like to show you a project here. So something that we made in one of my classes. I've got several, but here's an example that was made in class. So you can see the code for this is more complex. There's this asteroid. There's this one. There's this ship.
Oh
this ship. The Earth's code, as well as this background's code. So all of that code to make this happen. So it's actually a 2-player game. So there's 2 ships.
What?
You can, that he teleports. So to avoid the asteroids, I have to try and teleport. I'm trying to get to the Earth. It's actually a race.
Oh.
And that triggers the victory.
That's cool. Okay.
Yeah, so dun, 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 dun. Dun, dun, dun.
So all of those codes put together creates this, what is a mini game pretty much. It's a mini game, but it definitely took a lot of thought.
Well, yeah, they're mini games, but so for example, some major games like The Witcher 3 that took 5 years with a development team of 100 people to actually make that game. So when you have kids, so yes, it is kind of a mini game, but that's, until you're on an actual team and you're working with multiple programmers and using typically multiple programming languages, etc. You're going to have a game like this. But yeah, this is pretty complex actually I think for our younger students to put together, and a lot of thinking. So it's like setting a certain location. It picks a random location. So there's there is a lot to it. But yeah, it is kind of like a mini game.
Oh wow! And then so since Ticker is the hardest level, then I mean, this obviously looks different than the Scratch Junior. So now I'm like curious, what does Ticker look like?
Yeah. Do you want to see Tinker? All right, here, let me show you Tinker. So Tinker, I will share this. So here is Tinker. I got to do this a little different. Okay. So here's Tinker. So Tinker uses the same kind of Tinker is pretty cool actually. You can switch the programming language. So right now this is drag and drop, but if they wanted to learn Python, Java, any of those actual coding languages that are currently being used, they can. So far with our student base, we've been using drag and drop programming because it's already very complicated and it gives them that good transition. So if they want to continue coding and they aspire to be a computer engineer or a computer scientist, they could then pursue that later. This kind of gives them the foundation. So this is like a little game that I put together here. So it is like a tank game. So to see some of the code here, there's a ton.
A lot. Ooh, that's a lot of directions.
Ton of directions and triggers.
And the students will have to be dealing with all of this code, and if they do end up, pursuing, they find a love for, coding and everything, they definitely can go into computer engineering. You guys, computer engineering
Yeah.
Hello, it's the technology age.
Well, I mean, that's the thing. People, before you used to think, if my child, what's a field they can go into where, they can really have like a good, comfortable life. Everyone thought like doctors. Well, these days, I mean, engineers make almost just as much money. So, it
Mm-hmm.
really is a great field to go into in terms of, like financial comfort as well as the ability
Yeah.
to be, creative, that kind of thing. Not everyone's cut out to be a doctor. For me, I wouldn't want to be able to, that's too scary. A lot of stuff in that, so not for me. So, for
Mm-hmm.
if someone is like that, this is something that they might find a little bit more, enjoyable. So I think that's pretty cool too. So yeah, it's a great field to get
Yeah.
into. Really great field to get into. So just to show you here, so this is what the game does. That's ridiculously loud.
Oh, but that is neat.
And all of that code just to make that simple, you know. And like if we lose,
Oh my gosh. That is, I mean, it definitely has a new look. It's much more complex. And I mean, obviously, with how much code that's been applied, I mean, like you can tell the quality is definitely different. And it's really cool.
there's actually a lot there's a lot more to it. So one of the big things, the reason that I want to use Tinker and it's used often as an educational tool is like this right here. So in Scratch, all of your statements are true statements. What that means is, so like
Mhm.
if this is occurring, then this happens. What we can do with Tinker is you can actually set false values. So you can say, like, if this isn't happening, then this happens. So you can actually, if it makes sense, your architecture for the game, there's a lot more you can do with it because you can create conditions that apply to certain circumstances that you can't in Scratch. And
Mhm.
beyond that, there's tons and tons more blocks, more Boolean, all kinds of stuff. It has all of what Scratch
Wow.
has, but it's a lot more in depth. So it's a good,
Complex and everything. I'm sure
yes,
that this
yeah,
one deals with more mathematics
more
too.
mathematics as well. As you can see, like right
Hmm.
here, this is using like Bayesiers and some pretty. So yeah, definitely this one, and
Yeah.
you can switch it into other programming languages. So that's super cool. So that's
Wow.
Tinker. So that's what we're also teaching, and this is so that they can get a good structured approach to coding. So by the time they
Hmm.
finish with it, they should have a really good understanding of the fundamental principles.
Yeah, I mean, I mean, you guys, this stuff is something that they can take into their adulthood, like as a career. This is something that, like, will stem interest, and then after that, they can just build on it. Like the computer engineering field, technology field, just in general, is something that will continue to grow and just build and become better and better. And all of these, people, all these companies are going to need them. They're going to need
Yeah.
them. So this is a great foundation. Like, it was pretty easy to understand enough during the Scratch Junior, but you had me at at Scratch and what is it, Tinker? That one was kind of, yeah, that was kind of more complex. So that definitely keeps the students busy. And then what age group is for the Tinker?
So that's pretty much the same age. So Tinker, because it has a pretty structured platform. It goes all the
Hmm.
way from kindergarten all the way high school. So it's actually meant for
Whoa.
schools. So we actually have an educational account for Gulu Gulu, and so it's yeah, it actually we could code for any age that we wanted to. However, my classes predominantly are probably going to be with the kind of age group that we've been working with, just because when it comes to like HTML other forms of the more complex, like typing, when it comes to, input programming, I don't do as much of that. All I've ever really
Mhm.
learned was JavaScript. And so,
But even
and
that is, great. Like,
it's cool stuff, but I really like, I like the visual programming
mhm.
aspect, but we do have that platform, so there's a ton of classes. So I highly encourage any of our students, if they join with us, they can take those extra classes, so they can, if they want to try out C++, if they want to see what Python is like, any other programming languages, they do have
Mhm.
that option included as well. So
Oh, that's really good. That's a really great like system that we have put together, and you leading it, the coding classes and everything, and that's really good. I mean, I'm just kind of blown away at the fact that, how much really planning it really takes to build all of these things, and like how, I guess, structured the students have to be with their planning, with the story building, with the characters, the actions. The list goes on, but it's pretty neat.
and that's why when we structure the class, each one kind of focuses on a certain aspect, and so it builds. So some of them focus more on animation, some focus more on using using certain conditions, etc. So it kind of depends on each class, but it
Mhm.
focuses and it tries to to showcase a certain skill or principle.
Do the students in the class, do they have like group projects that they do? Like when they
We
can they
could,
mix?
you could with Tinker, actually, yes. With
Hmm.
Scratch, you would have to, you can take and you can remix a person's project. So
Uh-huh.
you could give your game to someone else, they could add to it, and then you could give it back. I hadn't done anything like that, actually, but that's definitely within the realm of possibility. In Tinker,
Hmm.
you can assign projects, you can do all kinds of stuff. So you can be like, all right, here, make the same thing, and I give you this, and then both students, one works on this character, one works on that character, and they put it together.
Yeah, but
Yeah.
that's good because it offers a good team building skills though too, which is
Oh yeah.
what you have to be able to do in the workforce. Yeah.
Collaboration, yes, yeah,
Uh-huh.
that's a good point. I haven't, we've everything's been in a group setting, but I've focused more on on solo projects and their own
Hmm.
project. But I like that idea, so that's definitely something I will consider here for maybe a modification to the curriculum.
Yeah, I mean, why not? If
Yeah.
that's a good opportunity to, put that team building aspect and everything, completing a project together and then seeing the
Yeah,
outcome,
real
you know.
real life applicability. Yeah.
Hmm. So, but that's awesome, like that was really awesome information. And yeah, Miss Karen said, Mr. Jacob is awesome,
Thank you.
appreciated all of your time and efforts teaching our students. So, yes, we definitely appreciate Mr. Jacob because Mr. Jacob is the tech guy. He's, the go-to guy for a lot of stuff that we don't know about. So we definitely appreciate it. And then you showing the students this really awesome and really useful skills for, not only just as a class in general, but also like something that they can take with them into adulthood. And if they pursue, a career in computer sciences, then like that.
That's the big,
It's
yeah,
awesome.
that's the big thing. I think it's, I hope it's encouraging, the next generation of really awesome software, really cool video games. Who knows? These kids are going to be creating the future. So
Yeah, that's
yeah.
a good point too. They are creating the future. So
Yeah.
like imagine the possibilities that could be out there for them just by learning, just by starting and
Exactly.
doing this, So, and that is awesome. Well, Mr. Jacob, thanks for, giving us that whole introduction and that little, like, pretty much like a demo of what it looks like and stuff.
Very
So,
welcome. Thank you.
yeah, that was really great. And you guys, if you're interested, I definitely recommend coming and asking some more questions, coming in to see a demo, coming to see, a trial class. Like, it's worth checking out. And the kids, you know, they are a part of the digital age. They enjoy, you know, playing these games. So why not take the opportunity to have them learn how to be the creator of these games?
That's what I was
Okay.
gonna say. They want to play them anyways, so
Mm-hmm.
why not take that and turn it into something constructive that'll benefit them, you know.
Mm-hmm.
If you want to
So
play it,
yeah,
well, you have to make it.
there you go. So create something that you like, designed by you, and then you can play it. So,
Yeah,
and then
exactly.
share with all the others. You know, could be profitable. Who knows? You know.
Yeah, yeah, definitely.
So that's awesome. Well, thank you again, Mr. Jacob, for all of that and, you know, sharing with us and everything. So, everyone, I am really glad that we had all of you guys watching today and then seeing all of this really great information. So if you want to contact us, please do. Let me go ahead and put this in here. Here is our information. We have our email here. It is contact@gulugululearningacademy.com, and our phone number here. And also, please do not forget to go ahead and share our Facebook page with anyone and everyone. Okay, like and share, because I know that there are definitely other parents who can
Their
definitely
kids could benefit
benefit.
from it.
Yeah, so there's a lot to offer here, but yes, please let us know if you have any questions. But, anyways, we
Thank
are
you guys so much.
glad that you guys came, and we will see you guys for next time. Bye, everyone.
Have a great night, everyone.